Why do we dream? Is it a window into our subconscious, or is it merely a byproduct of sleep? From ancient civilizations to modern scientists, dreams have always been swathed in mystery. Throughout history, dreams have fascinated scholars and lay people alike, prompting countless theories about their origins and purposes. These enigmatic experiences of the night continue to pique curiosity and provoke debate. What secrets do they hold about our minds and lives? Let's dive into the intriguing world of dreams and explore some of the most compelling theories out there. First up, Freud's famous theory, dreams as gateways to our unconscious desires. Sigmund Freud, the father of psychoanalysis, proposed a fascinating perspective on why we dream. He suggested that dreams are the royal road to the unconscious mind, where our deepest desires and fears reside, hidden from our waking thoughts. According to Freud, every dream is a fulfillment of a wish that we've repressed or suppressed during our conscious hours. Freud divided the dream into two main components: the manifest content and the latent content. The manifest content is the actual storyline of the dream, the surface level that we remember when we wake up. It's often bizarre and nonsensical. On the other hand, the latent content holds the true psychological significance of the dream. It contains the repressed desires and thoughts that are expressed through symbols and actions within the dream narrative. By analyzing these dreams, Freud believed we could gain insight into the unresolved conflicts driving our behavior and emotions. So, according to Freud, our dreams might just be our innermost desires trying to break free. Now let's shift gears to a more modern approach, the information processing theory. This intriguing concept proposes that dreams are not just random images or thoughts, but vital tools our brains use to sift through and make sense of the vast amounts of information we encounter each day. Imagine your brain as a highly sophisticated computer system that, during sleep, processes data, files away important memories, and discards the unnecessary details. Research in this field has shown that when we dream, our brains are actively organizing and consolidating memories. This is particularly crucial for learning new skills or information. Studies have demonstrated that people who dream about a new task perform better on that task the next day. It's as though dreaming serves as a kind of overnight therapy, enhancing neural connections and reinforcing newly learned activities or knowledge. Furthermore, this theory helps explain why, when we miss out on sleep, our cognitive functions like memory and learning are noticeably impaired. Dreams could be our brain's way of organizing the clutter of our daily lives. What if dreams are a part of our biological maintenance? Delving into the depths of our nightly journeys, there's a compelling theory suggesting that dreams are not just random firings of a sleeping mind, but actually serve a critical physiological function. This perspective views dreams as essential to the brain's development and its ongoing maintenance. Recent studies have highlighted how during REM sleep, the phase most associated with vivid dreams, there is a noticeable increase in neural activity. This isn't just a light show of the mind, it's believed that this activity helps to strengthen neural pathways. Essentially, dreaming could be the brain's method of defragmenting its storage, organizing memories, and optimizing mental processes. Moreover, this heightened activity during dreams is linked to brain plasticity, the brain's ability to adapt and reorganize itself. By dreaming, we might be essentially rewiring our brains, enhancing learning and emotional health. Perhaps our dreams are less about the mind and more about keeping the brain in tip-top shape. Could our dreams just be random firings in the brain? Let's talk about the activation synthesis model, developed in the late 20th century by neuroscientists J. Allen Hobson and Robert McCarley. The activation synthesis model proposes an intriguing explanation for why we dream. According to this theory, dreams are the brain's creative response to random neural impulses that occur during REM sleep, the stage of sleep most associated with vivid dreaming. The model suggests that during REM sleep, the brainstem generates random electrical impulses. These impulses activate various regions of the brain, particularly those involved in emotions, sensations, and memories. The forebrain then steps in, attempting to weave these random signals into a coherent story or scenario, essentially synthesizing a narrative from chaos. This implies that dreams might not have inherent meaning or purpose. Instead, they are the byproduct of the brain's relentless effort to create order from disorder. It's a bit like your brain watching static on a TV and trying to find a story in the noise. From a survival standpoint, why would dreaming be beneficial? Let's dive into the realm of evolutionary psychology. This field suggests that dreams might actually play a crucial role in our survival toolkit. They could be more than just random firings of a sleeping brain. They might be a deeply ingrained practice session for real-life encounters. Imagine this. Our ancient ancestors asleep in their caves or makeshift shelters. The world outside was fraught with dangers. Predators, rival tribes, harsh environments. In this context, dreaming could serve as a virtual reality simulator. By dreaming about various threatening scenarios, our ancestors could rehearse their responses to these threats. This nocturnal rehearsal might have honed their instincts, sharpened their reflexes, and prepared them mentally for actual encounters. This theory posits that such dreams are not just flights of fancy, but are, in fact, an evolutionary adaptation. They could have improved our ancestors' ability to anticipate and solve problems, thus enhancing their chances of survival in the unpredictable wild. Our ancestors might have dreamt to better prepare for the dangers of the wild. Dreams might also play a role in how we grow and develop cognitively. The intriguing idea that dreams mirror the maturation of the brain and our cognitive development, especially in children, offers a fascinating window into the human mind. As children navigate through various stages of growth, their dreams can act as a reflection of their evolving thoughts and emotions. This theory suggests that during sleep, particularly the dream-rich REM stage, the brain is not just resting but actively processing and integrating the day's emotional experiences. Dreams could be where children and even adults make sense of their emotional lives, piecing together complex feelings and thoughts in a safe, imaginative space. Moreover, these nocturnal narratives might help in developing problem-solving skills and enhancing memory consolidation. By reenacting certain scenarios or exploring new outcomes in dreams, the brain could be practicing ways to handle similar situations in wakefulness. In essence, dreaming could be the mind's playground for development, where cognitive skills are nurtured and emotional complexities are explored, all while we sleep. Could our dreams help us manage our emotions? Imagine your mind as a complex theater where nightly dramas unfold, not just for entertainment, but for psychological upkeep. Dreams might actually be more than random stories. They could be crucial in helping us regulate our emotions. This theory suggests that when we dream, we're essentially processing emotional experiences in a safe and controlled environment. Think of it as your brain's way of engaging in emotional decluttering. By reenacting and working through various scenarios and feelings, dreams could help us make sense of our emotional world. It's like having a private therapy session every night, where the mind rehearses responses to emotional challenges, refines coping mechanisms, and works through anxiety and fears. Moreover, this nocturnal processing helps prevent emotional overflow during our waking hours, maintaining our psychological health. So the next time you find yourself in a vivid dream, consider that your mind might be doing important emotional housekeeping. Perhaps our nightly narratives are a form of nocturnal therapy. Do our waking lives influence our dreams? This question brings us to the continuity hypothesis, a fascinating perspective in the realm of dream research. According to this hypothesis, the content of our dreams is not random, nor entirely separate from our daily lives. Instead, it suggests a seamless continuation of our waking thoughts, concerns, and preoccupations. Imagine your daily life as a film, each scene filled with its unique characters, emotional highs and lows, and unresolved conflicts. When we sleep, this film does not stop, rather it shifts into a different, more abstract mode of storytelling. Dreams in this sense are like a mirror reflecting the themes and issues we navigate during our waking hours. This theory also aligns with how frequently people report dreaming about places they frequent, people they interact with regularly, or ongoing projects and worries. It's as though our mind uses the realm of dreams to rehearse, review, and sometimes resolve the narratives we live by day. So, if you've ever wondered why certain themes recur in your dreams, consider your waking experiences. Our dreams might just be another stage where the drama of our daily lives continues to unfold. We've journeyed through some fascinating theories about why we dream, from the depths of psychoanalysis, where dreams are a window to our unconscious desires, to the realms of information processing, suggesting dreams help us sort and store our daily experiences. We explored the physiological function theory, positing that dreams are essential for neural development and maintenance. Then the activation synthesis model introduced us to the idea that dreams result from the brain's attempt to make sense of random neural activity during sleep. In evolutionary psychology, we considered dreams as simulations, tools for problem-solving and survival training. Cognitive development theories argue that dreams reflect our cognitive growth and understanding of the world. We also delved into how dreams might aid in emotional regulation, providing a safe space to process emotions. Lastly, the continuity hypothesis suggests that our dreaming and waking thoughts are part of the same continuum, reflecting our concerns and interests. While the definitive answer to why we dream still eludes us, the quest for understanding continues to inspire both scientists and dreamers alike.